Assalamualaikum and hi everyone. My name is BINTI ABDUL from Group 10. So for today, me and my group will present the gifted assignment, which is question number 6. Okay, as you can see here, the question asks to construct and simulate a single-phase full-bridge inverter with Spwm control technique. And this is the parameters given that we can use to construct the circuit. And this is the measurement for simulation result. Okay, now let's have a look at the circuit that I already construct with my friend. Okay, here is the circuit. Okay, first we look at here. Okay, this is DC supply voltage. DC supply voltage given is 150 volts. Next, semiconductor power device. Okay, as we know, for the single-phase full-bridge inverter, it consists of 4 power switches that are S1, S2, S3, and S4. Okay, from the question, we use ideal IGBT as the power switches here. Okay, next is AC load. Okay, AC load, we can put it here for R and L. Okay, R given is 25 ohm and L 0.04 Henry. And this is V out, I out. And this is I out. Okay, next. Okay, let's focus at this part. Okay, this part. Okay, this is reference signal and this is carrier signal. So first, we put 150 volt here. Okay, where do I get 150 volt? From the okay, from this calculation I got VC 150 volt, so I put it here, and 100 hertz is this one, output frequency 100 hertz, and then this is modulation index 0.8. Okay, when we run the simulation, 150 volt will multiply by 0.8 and we'll get the reference voltage, and then we can get the reference voltage. Okay, next for this carrier signal part, we use triangular source, and this triangular source is in the unipolar signal, so we must shift a little bit to be the bipolar signal with the function of 150 volt DC source here. Okay, and then this is voltage peak to peak, and this is the carrier frequency. How do I get 1000 hertz? From the calculation. Okay, as we know, the carrier ratio is 10, so we multiply with this one, 100 of frequency, and then we can get the carrier frequency here. So we put it here. Okay. Next, for the measurement for simulation results. Okay, my next presenter will present it. That's all from me. Thank you.
Assalamualaikum and hi, my name is SURAYA binti HAMSAN. So I want to continue to explain for measurement for simulation result for question 1 first. So question 1 here us to want to see is positive and negative cycle of VC. So basically VR is equal to V sines and VC carrier signal is equal to V triangular. So have a look what we get. for the result. So we sines and re triangular. So okay, so this is the result that we get for reference signal and carrier signal. So for the negative cycle, I change to negative, and then to this is for negative also. So we run the simulation, and then there we see. Basically this is the result that we get. So the difference between the positive and negative is the carrier signal is inverted. So basically this is the difference for negative cycle. So okay, I change to the original back. Change to original backs and to original back. So we gonna look for the question 2. They asked to signal of PWM1. So first we need consider the switching rule. So switching rule, when the VR more than VC, the value of PWM is equal to 1. When VR less than VC, the value of PWM is equal to 0. So okay, I want to run this simulation. Okay, we science and with apples. I will add this first, and then I will add the PWM1. So we can see when we are more than VC, at this point we are more than VC, and then the value of V SPWM is equal to 1 at the point of VR more than VC. So for the VR less than VC, the value of VSPWM is equal to 0. So we get what we want for the question 2 for signal of PWM. So and then for the next question is V out. So V out. For V out. So for V out, okay. Okay, basically this is the result that we get for V out from 3 second to 3.02 second. So that's all from me. Thank you. For the next question, the next presenter will explain it.
Assalamualaikum, and my name is FAIQAH ATHIRAH, and I will be continue the presentation. So the question asks for output current. First thing is you have to run the simulation and choose the output current. Then there is the waveform of output current. Next is question asks RMS measurement of a complete cycle of V out. So the first step is still the same. You run the simulation and then choose V out. This is the waveform of V out. And then the question asks for RMS measurement. So click measure tab, measure again, and take the time from 3 seconds to 3.02 seconds, and the average voltage output RMS is 0.525262 volt. Okay. Next is harmonic spectrum of V out and I out. Still run the simulation. This time, choose I out and V out as the variable. Then this is the waveform of the I out and V out, but the waveform is in time domain. The question asks for harmonic spectrum, which is in frequency domain. So you have to change the waveform to FFT, fast Fourier transform, which is in frequency domain. So next, the question asks to set the x-axis as follow. Axis, x, linear from 0 to 5 kilohertz. Okay, so we got the output current and voltage current for harmonic spectrum. That's all from me.